Ids Project. Group members 16 UCC 002 Aashi Bhatia, 16 UCC 013 AKSHIT Singh, 16 UCC 014 Adarsh Shrivastava, and 16 UCC 035 HARSHIT DHUPAR. Our project is on ML classification for a dataset about improving accuracy of detecting healthcare quality. This dataset contains 131 observations and 14 attributes with member ID, inpatient days, ER visit, etc., goes up to poor care. Poor care is the outcome or dependent variable and is equals to 1 or 0, depending upon if the patient had the poor care or the good care. So, in our model, we use basically to train our model to detect poor care cases for the test set with the high accuracy, we will be using the algorithm logistic regression. Logistic regression is a powerful statistical way of modeling a binomial outcome, which takes only the value equals to 0, having, or 1, not having a disease. For example, having or not having a disease with one or more explanatory variable. The advantage of using this very logistic regression is that first you can also include more than one explanatory variable that is a dependent variable, and with those can either be ordinal or continuous. The second uh, is that logistic regression provide a quantified value for the strength of the association adjusting for the variables. The exponential of the coefficient correspond to the odd ratios of the given factor. The logistic regression is also important because it is an appropriate regression analysis to conduct when the dependent variable is binary. Like all the regression analysis, the logistic regression is a predictive analysis, and logistic regression is used to describe the data and to explain the data between the one dependent binary variable or maybe one or more nominal, ordinal, or interval or ratio level dependence variable. Sometimes logistic regression are difficult to interpret. But now, first, here we can see that blue lines are signify our code, red lines signify comments, and the output is shown by the black lines. So first what we do is that we read our CSV file, which will print the data frame of about 131 into 14 matrix. And then we find out the summary of our data, which will show the minimum and mean and median, etc., about the different attributes. And then for our model to increase the data frame, first we find out the 0 1 value, the number of 0 values and the number of 1 values in the poor care. If there's a 0 value, it will represent the good care, and if there's a 1 value, that will represent the poor care. And if the patient receive poor care, the patient who receive poor care are about 98, and the patient who receive the patient who receive good care are 98 and the patient who receive poor care are 33. So here you can see that accuracy of good cases is 74, and that our job is to increase that accuracy. And for that, first we are going to use a library CA tool, which is going to split the data into two sets, which is a training set and another one is test set. And after that we are going to implement a model. We are going to actually implement three models containing different attributes. First we take attribute office visit, narcotics, ER visit, and total visits, and then we find out that there are only uh, attributes which have significance. As we can see that the PR value in this case for the intercept and narcotics is very less, and that is why they are significant attributes with AIC value equals to 88.67. Actually, AIC is an estimator of the relative quantity. So we can see in another model too, again, that we get office visit and narcotics and ER visit. And in this case also we see that the PR value for intercept office visit is more than narcotics. So we find out that the narcotics and intercepts are still the significant attributes than other two. And then we again select the another model which contain office visit and narcotics only. And in this case, we find out that the PR value is very less for all the cases. So we use, and there's a AIC value equals to 86.815. So that's why we use this model as it is the best model with the less AIC value. Now we are going to do is that we are going to predict this model using type equals to response. And for that, we are going to first predict the threshold. For that, we use ROC curves by using the library called ROCR. ROC curves are actually ROC curves are used to see how well your classifier can separate positive and negative example and to identify the best threshold for separating them. To be able to use the ROC curve, your classifier has to be ranking, and that is it should be able to rank examples such that the one with higher rank are more likely to be positive. For example, in logistic regression output possibilities, which is a score you can use for ranking. If there's a dataset given to you and the order of the test example by score from the highest to the lowest start from 0, comma 0. For example, x is the sorted x is in the sorted order. If the x is positive, it moves up, and if x is negative, it moves down, where position and pose is and neg are the fraction of positive and negative respectively. Then we can see that in that type of graph, y-axis is positive rate and x-axis is false positive rate. Note that the diagonal line that is the baseline that can be obtained with the random classifier. Thus, the further our ROC curve is above, the line is better. So this is most about ROC. And now, after that, we are using the prediction function to predict ROCR and then performance. And then we are going to plot the performance of ROC. And now we calculate the confusion matrix for our test cases. The confusion matrix is actually the important tool to predict the output of a model and examine all the possible outcomes of our prediction. That can be true positive, true negative, false positive, and false negative. Confusion matrix it also calculate observed and predicted classes with the associated statistics. And then after that we take the threshold equals to 0. According to these results, we take the threshold equals to zero point 0.3, and from that ROC curve gonna predict, and also our accuracy will be increased up to 31 by 39, that is 79.48 percentage. That means there is an increase in accuracy of about 5%. And that's all we have to do in our model. Thank you.